Hello. This project serves as the foundation for a comprehensive Power BI management application. It collects, updates, and displays data related to Power BI activity events while addressing challenges such as periodic data fetching from the Power BI REST API and Microsoft's limitations on data retrieval, including the 30-day restriction and API call limits. The application enables long-term analysis and improved resource management through features like a custom REST API for advanced queries, CSV export for detailed analysis, and an interactive dashboard for visualizations. Asynchronous task management with Celery ensures efficient operations, laying the groundwork for a robust Power BI management solution. This project was made for the final submission of the CS50's Web Programming with Python and JavaScript course. Let's briefly cover the installation process. Once you have the repository cloned, it's as simple as running the following command to build and set up everything needed for the application. Docker compose build. Next, execute this command to start the containers. Docker compose -ppb I_manager up-d. Now the application should be up and running at http://localhost:8010. As you can see, there's no data displayed yet. That's because you need to fetch it from the Power BI API. To do this, you'll first need to register a Microsoft Service Principal through the Django admin interface, and then you can fetch the data. Here in Service Credential section, you can enter the credentials. After that, you can click this button to check if the Service Principal API successfully authenticated with Microsoft Entra. Once the Service Principal is registered, you can navigate to the model called Activity Events, where you can retrieve the activity synchronously by clicking this button. For the application to function properly, it's also mandatory to configure Celery Beat in the corresponding section to perform the fetch task asynchronously at defined intervals, which you can do through the admin interface. In the Activity Events Fields section, you can define which fields are displayed, determine which ones will serve as filters and sorting options, and select the fields to be used for chart visualizations, as the Activity Events model contains 47 mapped fields. Additionally, you can assign more descriptive names to these fields. Now, we are going back to the main page. This example uses fake data to avoid exposing organizational information. Injecting fake data is simple, thanks to a dedicated Django command provided for this purpose, detailed in the readme.md. Here we have a table with all the activity events, and you can filter and sort them based on the fields selected in the Django admin interface. Additionally, you can export the data to CSV, applying the selected filters and sorting criteria. Now let's check out the charts page. This line chart shows the frequency of activity events over different time units, from year to hour. You can select legends to group the events by your chosen criteria, making trends easy to spot. With a single click, you can exclude a category from the chart, which is the default behavior of the chart, JS library. A feature was implemented for this project that allows focusing on a single category with 2 clicks. Additionally, there's a bar chart that updates based on the fields you select for charting in the admin interface. You can make these selections using this drop-down box. I hope you enjoyed this video. Thank you for watching.